Alright, hello, welcome back to another stream. Just getting stuff started here. Man, a young stream, we already have spam. Train. Alright, do we have a cat? I think the cat's wandering right now. But, yeah, let's see. Hi. Oh, there's the cat. I think he might be on his way over. And the train. Alright, yeah, he's trying to come over here. So, yeah, I've been a little reluctant to get the stream going today, mostly because I kind of hate context switching. I'm always really interested in getting to the next step and, you know, figuring out how to get past whatever problem I'm on. So I've been reluctant to put this thing away. So I might really quickly kind of document what's going on, because it is actually somewhat related to the main topic I wanted to get into, which is this USB device emulator doodad, the Rasp Dancer, which is a Raspberry Pi adaptation of the Face Dancer board. And so I wanted to try that to see if it would be fast enough to emulate this debug adapter in a usable way. We tried doing that with the Face Dancer in a previous stream and got it working, but really, really unusably slow. And this is basically the same idea, you know, the same design as the Face Dancer, but instead of kind of doing general purpose I/O operations through a serial port, through a microcontroller, this connects the chip directly to the Raspberry Pi SPI ports. So it turns out that with the Raspberry Pi 2 and 3, the GPIOs are surprisingly fast. I'm sure a lot of you already knew that, but this is news to me. And you know, so for example, you can use the, you know, as long as you're using the kind of chip-specific, you know, GPIOs, where you're writing directly to the registers in memory and not the sysfs abstraction, you can actually get, you know, you can bit bang clock rates of, you know, 6 megahertz or whatever if you want, and so there's actually a pretty nice module that you can conditionally compile into OpenOCD, the kind of on-chip debugger tool. And if you run that on the Raspberry Pi, you can actually just have that communicate over the serial, you know, serial wire debugging port, SWD, sort of a one-wire JTAG. And you can just have it communicate with that and load firmware or remote control the process, you know, change registers and stuff. And I've been interested in that kind of, you know, processor remote control for various reasons. Some of you might have seen this article I wrote for POC or GTFO pretty recently, actually, that it was like an Arduino implementation of that one-wire debug protocol, so that you could, it was something that I had originally written for the kind of factory test harness for my Fade Candy LED controllers, but then I adapted it as kind of this thing that you could just like stick a ESP80, you know, stick a, like a, you know, whatever ESP dongle or Arduino with Wi-Fi or just whatever Arduino you have on something. And then in the example, I had like a web page you could use to access the target memory over this protocol. So this test jig, I was actually trying to, this is a continuation of something else that I worked on a previous stream, where I was just trying to establish communication with this Ethernet microcontroller that I'm slowing way down. Oh, I just checked the chat, and I'm sorry, there's a complaint about the streaming quality, and I realized I forgot to stop my backups. That might help. I really should learn to do this. Okay, I think if I stop that, I don't know if I have to restart OBS for that to get better. Let's see if YouTube likes it now. YouTube says my stream is orange, whatever that means. I'm going to try to avoid disconnecting it. I think now that I'm no longer sucking up lots of bandwidth with my backups, this might get a little better. Looks like so far it's still pretty laggy. All right, let me give OBS a quick restart. I think that fixed it last time. Sorry about the interruption. We'll be right back. Stop streaming. All right. Oh, now that I'm looking at the stream on the YouTube view, it looks like it might have actually cleared up kind of right before I reset it. I don't know why it's still orange, but whatever that color means, it seems to at least have better frame rate now. So, yeah. Well, let me do a really quick kind of tour of what's going on. I've actually maybe got something to show that might be worth recording on the computer, so I will start that recorder and be right back. Also, Tuco has joined us, so I will actually set up the Tuco camera. Let's see. Yeah. Tuco cam. All right. Cat's joining us. Aw. Cute little fuzzball. All right. So, let's see. So part of why this week has felt kind of frustrating is that there's just a steep learning curve on every experiment I want to try with this microcontroller. You know, like I wanted to at first see if I could. Well, so winding back just a little bit, I'm trying to do this lower speed communication where I underclock this particular microcontroller and then I try to see if I can still talk to it over Ethernet. And so in the past I was doing that with the peer on the other end being one of these 10 base T SPI attached Ethernet chips, the ENC28J60. And that worked to a point, but then I underclocked it even more, and it looked like I was hitting limitations that just seemed to be, you know, problems with the design in the PHY on that chip. So just like at an analog level, it was having problems that the TI chip wasn't. So to get around that, the best solution seems to be to just try to make the other peer also, you know, be the same chip. So to get one of these same TI TIVA chips to just act as an Ethernet interface that I can slow down as much as I want. And so then I was going through a bunch of different ways to do that. So I thought, you know, it would be really convenient if, well, I think to maybe frame this in a slightly broader way, I get really nervous when it seems like there are too many degrees of freedom in a problem. Like if I could just make, you know, anything I wanted on the driver side and on the firmware side, and you know, if there's this opportunity to just go write a whole bunch of code, then I'd like to go find an opportunity to not have to write that much code, and maybe, you know, give myself a few additional constraints in a problem that's already so under-constrained in order to take advantage of some existing pieces people have written. So in that spirit, I thought it would be really cool if I could just program this microcontroller to emulate that same chip I was using before, since it already has a really convenient driver for the Raspberry Pi. As far as I know, it's like the only, well, it and the 100 base T version of the same chip seem to be the only, like, you know, working SPI attached Ethernet devices I could see in Linux. And SPI isn't mandatory, it's just easiest to have something like that I can kind of change the clock rate of the implementation behind it, and the protocol doesn't necessarily care. So then, you know, I go through here and I'm thinking about how to implement that controller using, of course, their SPI peripheral is extremely generic, because not only does it have, all sorts of DMA features, it is designed to have between, 1 and 4 bits of parallel data, so it's the quad synchronous serial interface, and it supports all these different vendor formats. What it doesn't understandably let me do is implement the piece in the ENC28J60's protocol where, like, pretty much right between one SPI byte and the next SPI byte, I have to decide what data to be giving back to the SPI master. So just due to the way that protocol is designed, I can't, it requires a much lower latency than I can achieve with any kind of software. So, then I was looking into other options, and I was thinking about, again, ways to kind of avoid writing as much just completely, brand new code. And so there's already, I don't want to have to rewrite necessarily the Ethernet driver layer if I can avoid it, since that stuff is, also fairly complex. It turns out that I'm probably still going to have to deal with the hardware at a pretty low level. But that's fine. It just means I have to go learn a bunch of things. So actually, if you haven't come across a piece of hardware that has basically a lot of what you see is the difference between a piece of hardware that supports the DMA operations that would be necessary to implement a kind of full-featured operating system versus hardware that can only really do, kind of a single, at worst, like a single byte. You give it a byte and then it gives you an interrupt when it wants another byte. That's like the dumbest piece of hardware that you could still integrate into an operating system. But a lot of pieces of hardware, you give it, you can have like an entire DMA operation that's, a buffer full of bytes. But then there's another level beyond that a lot of pieces of hardware reach, especially things that tend to be pretty high throughput and involve kind of complicated data structures like Ethernet and USB. And those, then you get into things where the hardware actually has like a linked list of DMA buffers that it has to follow. And so that's kind of what this is getting into. And so I've got something that seems like it should work, but it doesn't quite work. And so I've got to do some more debugging on this, but yeah, that's basically where I'm at right now. My plan here was to have a, basically a small stub program that I compile into, and load onto the flash memory. And so this is using, basically TI's library style, but compiled using kind of an open source variant of that, of their libraries that work with GCC. And so all of these turn into either calls into ROM with utility functions that total registers, or they'll just expand into direct register accesses. But the important thing is that I want to set up this chip to be as similar as possible to the other one that I'm underclocking, so similar PLL settings and things like that. And yeah, my plan here is just to use this to configure the hardware and then basically have this get stuck in a loop where I have an intentional breakpoint here that when I attach a debugger, the debugger will just stop there. It'll give me an opportunity to adjust those data structures in memory so that the hardware will see additional packets to transmit, or I'll dequeue packets that it's received. And then when I'm waking up from the debugger, this is actually just a little register poke that tells the state machine in the Ethernet MAC, the media access controller, like basically the little bit of hardware that actually shuttles the packets back and forth, that actually just wakes it up and has it look at that list and see the bit that I've set to indicate that it might have some data ready. So I'll be going a little deeper into this in the future, but that's pretty much where things are right now. Let's maybe get the camera pointed at the stuff that I'm taking apart, and then let's put some stuff together. Yeah, this setup was pretty simple. I wouldn't even necessarily need the Ethernet on the Raspberry Pi side, except I was hitting some kind of weird problem with SSH that seemed to be related to the Wi-Fi. And the only mentions I could find of a stall at that particular point in an SSH login seemed to be related to some kind of network configuration that was throwing out packets with a particularly large frame size. So, don't know what that was about. But all I'm doing here is just powering this board, and then these wires are clock and data for the serial wire debug protocol. I had this set up to visualize that on the scope earlier. I think I posted a screenshot of that to Twitter. Anyway, let's leave that connected and just get my Raspberry Pi free for this next experiment. Oh, I guess before we get really into this, and while I'm still kind of in this like vague topic of things that I have made not as much progress on this week as I would like, I still continue to improve the streaming setup around here a little bit. In particular, I kept hitting this stupid bug in Synergy where I would be zoomed in on the desktop computer, and then my mouse would get stuck, and so I've got like a little stupid dedicated wireless doodad that I can use to start and stop the stream now, so I don't have to even use Synergy. And I've been experimenting with different ways of changing the channel on OBS, between all the different cameras and different inputs. So this one's actually one of my favorites so far. Previously, I was using like a Bluetooth presentation clicker that had up and down arrows, and that worked all right if I had the keyboard focus in the right spot, but it didn't really have anything that I could hotkey in a more global way. But with numlock on, I can just kind of, well, okay, when I accidentally turn off numlock, then things stop working, so I have to not do that. But otherwise, I can just kind of poke things and switch between channels pretty easily. So that kind of tells me a little bit more of what I want. I don't necessarily, it's not quite the right form factor still, and it would be nice to not have the wireless that kind of has to wake up the first time you use it after a while. That introduces some lag. It'd be nice not to have to make sure numlock is on. So I had this idea to maybe combine a few things and do a little project that would give me some footage of manufacturing some stuff that might be interesting here. So flexible electronics and in a flexible 3D printed case, and it would also be something that would be super useful during streams. Because what I would really like is something where, let me get a better view of this. Oh, also, hi Kat. So I've got this stuff around here mostly mounted on these metal poles, kind of lighting poles, and so I've been doing something similar on the other side with kind of putting magnets on remotes and stuff and sticking things to the pole when I'm not using them. What I'd really like on this side, oops. Yeah, what I'd really like is something that can just kind of grip onto the pole here. And imagine just a, for starters, something that's kind of a rectangle about that size, but then it sticks on and kind of conforms to the pole, and then maybe gives me, 5 rows of 3 buttons that are kind of tactile, and then has a kind of subtle USB micro tail on the bottom. And I'm thinking that it could be something where I make it, so I've got these little, I got a couple of orders of just random tactile switches from the internet, just to have something around for this this experiment. And I think something like this actually, just surface mount soldered to kind of a homemade flexible circuit board made with that Pyrolux on the mill, and then that could be housed in probably a 2-piece flexible 3D printed thing made of like Semiflex or NinjaFlex. And so sandwiched in there, I could also put magnets. So that when I kind of glue both halves of the case together, the magnets would be in there quite solidly, and it would hold the thing to the pole. So I think that might be a nice kind of project, a nice kind of confluence of different things. Something that gives me some more interesting fabrication footage, but also has context that's actually related to stuff I'm doing here. Oh, I've also got another thing that I've been working on This was a while ago, but it was an experiment in trying to make tactile buttons that were all molded in a single piece of flexible 3D printed stuff. Yeah. I posted this on Twitter and Thingiverse a while ago. So some of you might be familiar with these little synthesizers. It's the Pocket Operator by Teenage Engineering. And this is my experiment in trying to make a one-piece 3D printed case for it. Focus. All right. So it's it has some problems. I mean, I actually ended up breaking the LCD very slightly. There's a little crack on the edge trying to get it in. So I wouldn't necessarily recommend other people try to do this. And the feel is all right, but it could be better. Like I would like it if it was slightly less stiff, although it's still pretty playable. And I tried to, so there are features internally that try to, sorry, this camera focus is really bugging me. So I tried to use some internal features to, to give this different levels of stiffness. So like back here, it's a pretty spongy kind of rest that gives it like a foot to sit on. The edges are pretty strong. There's like a strongish kind of substructure in the button that gives the button itself some rigidity. But then there's like a thinner membrane connecting the button to the rest of the case. So yeah, this is fun. So this definitely inspired me to try doing more things with that technique. And I think this combined with flexible circuit boards and maybe a way of doing a two-part print and then either heat welding them or gluing them together. So that's definitely going to be a project in the pipeline, potentially pretty nearby since, even if I end up doing a video about that particular project a little later on, it would be nice to have some of the manufacturing footage for just a general PCB assembly sort of video a little bit sooner. All right. Just check on the stream here. I just noticed a comment that the original naked design was prettier. I don't disagree. I think this design certainly depends on your tolerance for relatively rough 3D prints, since it's hard to get a super nice looking print with flexible materials at home, since both of those are kind of working against you. But I kind of like it, especially with the clear. So certainly not for everyone, but I thought it was a worthy experiment. And I certainly still play it with the case on like this. Okay. So, switching gears slightly. Oh, this cat is so cute. You should all be able to see him. There we go. That's a little better. All right, so the Rasp Dancer. This is the little contraption that we built, I guess last stream, a couple streams ago, pretty recently. So it is really just a face dancer, but with the good FET replaced with a Raspberry Pi. So instead of having your Python program talk to this through a bunch of intermediary stages, it's just plugged directly into the SPI channel on the Broadcom chip in the Raspberry Pi. So it gets a much faster pipe to your Python code. Don't have to worry about USB latency. Don't have to worry about the serial port to the MSP430 or its firmware. And so some of this, well, let's see, maybe it's worth talking about this fabrication very slightly. So, I mean, this board definitely was not optimized for this particular fabrication technique. If we wanted to make a design for this board that was really easy to fabricate at home, then it would probably, we'd probably not have vias under the processor. I would definitely change the spacing of the passives. I looked back at the design, and it does actually specify 0603 parts for this, but assembling it with 0603 and no solder mask actually just would leave the part just sitting on the gap with, the trace kind of between its two pads, and it would just short things out. So I ended up having to kind of let the passives hover above the board a little bit to prevent that from happening. So there are definitely things that you would do differently. Oh, which one is it? That one. Definitely things you would do differently if you were actually optimizing this board for this technique. But, if this board is designed for just, kind of regular mass manufacture techniques, and you're just doing this as a prototype to validate aspects of the design, then it wouldn't necessarily matter, as long as you, you take into account what you've changed, and that doesn't actually affect your ability to test the things that you need to test. So, and like, for example, I know that if I just had the right crystal footprint, that would be fine. I tried placing another crystal that was just the wrong speed there, and it fits. I just didn't solder it on. So if I needed to validate this design, even though I had to bodge it a little bit to actually do the assembly, I think so far this would actually give me a good idea that this design would work when I send this off for manufacture later, or when I give it to someone else to assemble. And so that's another optional piece. So this is actually a jumper that you can put in if you want to power the Raspberry Pi from this USB port, which I do not, so I'm leaving that out. One thing that we lucked out on, actually, is it can be really annoying to solder a header, especially from the side that's mechanically blocked off. So for example, I actually got some of these 26-pin headers for this project. Usually I don't have the right size headers, and I have to make do with something else, but Raspberry Pi sized headers seem useful. So yeah, typically you would end up with this kind of pressed all the way up against the board, and if you had to solder the pins to any of those rings there, then it would be difficult. The way I would usually do it is to leave a little bit of extra space and then go in with the soldering iron from the side, but it's kind of annoying. So we're lucky on this board, or possibly this was done intentionally, so that the signals all come out on this side, so it isn't necessary to solder the pins on the other side of the board. So in this case, we just have to solder this pretty normally. I'm going to place this on the Raspberry Pi to see if it's useful to have any space, because these pins, we could solder this with a bunch of space if we wanted to, or if we needed to. All right. Let's unplug this Raspberry. Alright, I was careful to check over the pin 1 last time because it's a little bit weird, but it plugs in right around here, and it doesn't look like we need any additional space. In fact, it might be useful to take off some of that spacing, but it should be fine. So, yeah. And, yeah, so I might as well leave those sticking up either for logic probes or for stacking additional stuff. Just a little bit of solder, and then we can test this board. I think I just need to enable SPI on this Raspberry Pi, and then grab the Python patch for this board from the contrib directory and splat it over the main face dancer Python module. And that autofocus is really not doing any favors today. without squishing anything. Be fine if I didn't want to get it on the microscope, but I kind of want to get it on the microscope because I like the close-up view sometimes. That's going to cast some weird shadows. That's better. All right, setup is all set up. Oh yeah, a few people have pointed out that the microscope is interlaced, and I'm aware. I had the configuration doing deinterlacing in software, but I turned that off recently to see if that would help with my kind of CPU deficiency on the streaming machine. But I do deinterlace the stuff that I record for the edited videos, and I'm going to try turning that deinterlacing back on, I think. I'll definitely turn it on once I get the streaming going on a faster computer. It's giving me these ugly little tails. Like it doesn't quite have enough flux to avoid that on its own. Other than feeling really dumb for not being able to get that Ethernet transmitter to actually Ethernet transceiver to actually transmit my frames, I think my Friday is going all right. Hope everyone out there is having a good Friday, or at least planning on having a good weekend. I often disable those thermal relief pads when milling boards because they're just kind of annoying, and they can just make I don't know, I just feel like they don't really help that much, and it's extra milling time for not much good. But of course, you know, if you're milling the design exactly as you're planning on sending it to the fab house, then it doesn't hurt. I'm not heating up the other side of that quite enough. Alright, fine. With these non-plated holes, there really isn't a lot of metal for the solder to grab onto. So there's this strong tendency for it to, you know, to have stronger surface tension cling to your iron than to that little bit of metal on the circuit board. This could be prettier, but yeah, prototyping. I mean, the kinds of electronics you have to do once versus the kinds of electronics you have to do, you know, for every manufactured product, very, very different. I usually prefer the stuff that only has to work on my workbench, but, you know, the stuff that has to work in a much more, you know, diverse environment is pretty interesting. Oh, see that one? I thought I was getting most of these soldered all around, but I mean, it doesn't matter that much, but it isn't a great solder joint. That's just like a blob of solder clinging to the pin, and just like, oh, there's a little bit of copper here. I guess I'll touch it, sort of. It seems hot. Oops. I think I just spread some solder somewhere it shouldn't have been. Yeah, that would have been annoying. I think doing prototyping with kind of weird materials is pretty interesting, especially as a demo, because it gets people thinking about like, well, what can I do if I'm not limited by the menu of techniques that some manufacturer has to offer? You know, what if I'm just doing anything and I want to see what works? And so, actually, one hacker you should definitely check out. I keep forgetting his real name, but his handle is CNLohr, CNLOHR, and he's been doing some neat live streams lately on reverse engineering the USB protocol that's used for like compressed updates to the Vive like position tracking beacons, the lighthouse. So that's been pretty interesting. But one of his kind of earlier YouTube projects involved fabricating circuit boards on glass, you know, using chemical etching, and so. And then I've been thinking about, well, how easy would it be to do, you know, sort of flex rigid PCBs with different materials using the mill. And I'm thinking, you know, like sandwich materials together and then mill a circuit on the top side and then maybe flip it over and then mill pockets on the underside to take out different layers of that lamination. Anyway, that looks pretty straightforward. None of the pins seem to be shorting. Ooh, sorry about that. So, let's see if we can power on our Raspberry Pi and do something interesting with this. Hopefully not see any magic smoke escape. Our cat cam's doing all right. There's a comment from Wildmania in chat that long sleeves will end up with parts on the floor, and that's a risk I take when it is cold in here. But yeah, I do have another work jacket that doesn't have dangly sleeves that I probably should switch to when it becomes a problem. All right. I think I've already got this one all set up to like SSH into, so I don't think I'm going to bother with HDMI or any of that. Try to gingerly grip this thing with the vise. Oh, actually, I think I have a Raspberry Pi case that might work better for this. I can just use half a Raspberry Pi case. I don't think the top half will fit. I think this will work out slightly better if I actually bother to put in the screws, because otherwise the cables are going to pull on it. These are M3 by 8 millimeters. I hope they're small enough. They might be too long, but it'll be better than nothing. I don't think it'll short anything out. I think these are actually supposed to be like M2, because this is also a little too wide. Huh. Might have smaller screws. I don't have anything easy. I'm not going to worry about that now. Let's see if I can plug stuff into this without it getting pulled out of the case. So I've got Ethernet and power. Still so many wires. Just need those wireless oscope probes. Oh, that would be a terrible idea. The lights are coming on. Okay. I think the next steps all involve seeing if we can talk to this thing. All right. Okay. I think we can follow the instructions in this project. So we went through this a bit in an earlier stream, but in case you missed that, this is a variant of the Face Dancer that came from the contrib directory in the Face Dancer part of the goodfet repo, or rather the goodfet/contrib/Face Dancer/Rasp Dancer is a version of the Face Dancer for the Raspberry Pi. Yep. And according to this README, the PCB hasn't been tested, so maybe we're the first, or maybe nobody's updated this yet. And so we should, according to this, get 26 megahertz SPI here. Here's all the info about populating it, activating SPI. I think we can use the Raspberry Pi config to do this part now. But then I think the rest of this is probably reasonable. So let's SSH into the Raspberry. All right. Interfacing. Why, yes, I would. Thank you. And I don't think on some of my Raspberry Pis, I have that ENC28J60 overlay enabled, but let's just make sure that isn't enabled here. So yeah, if I was using the ENC28J60, the easiest way to enable that is by using a device tree overlay here, but not using that, so we shouldn't have anybody else trying to use that SPI bus. Let's reboot this. Let's see what else. There we go. I think the slowest part of actually bringing this up is doing the multicast DNS, but we are back. Man, this is a little bit janky. Is there a better way to install this? Man, that wind is loud. I don't know how much of that is coming through over the microphone, but there's a lot of wind here right now. So I don't know why this is having us like wget individual files. I think I'm just going to grab this repo and try installing it normally. All right. That seemed pretty successy. And then there's another library right here that we need. I'm curious how fast this is going to be, because, you know, it's using the I mean, it's using the hardware SPI, and all of the overhead involved in these wrappers is only going to take place per SPI transaction. So a lot of it's going to depend on how often we have to talk to the Maxim chip per USB transfer. Let's move to SourceForge, or is it on PyPy now? Okay, I guess this is used concurrently. Oh, okay. Never mind. I guess this is pre-installed on Raspbian. I missed that part. What is the name of this module? Let's just take a look at the source. Why not? Ooh, fun. Good little C module. Is that honestly the name of the module? rpi.gpio? Okay. That capital R, capital P, lowercase I. Yeah, that's convenient. Let's just make sure that's installed. Great. Alright, well, maybe we have everything we need now and we can just try this out. I think it's going to tell us to yeah. Yeah, replace the original goodfet.py with the version provided here. So let's try that. I think that is up a few levels here. Client, yeah. All right, let's try something simple. Dancer FTDI. It's probably going to need root. That shouldn't even need to be talking to a serial port, right? So, seems straightforward. It's got some good bit bang in there and some SPI. Well, maybe it just needs like a dummy serial port. What do we have? We use the Raspberry Pi's built-in serial port. That's like TTY ACM or something. TTY ACM 0. Oh right, that's not the Raspberry Pi. Oh geez, was I running that on this machine instead of the Raspberry Pi? That's a silly mistake. Alright. Let's try running this on the Raspberry Pi. Clearly I should be differentiating them by the Raspberry Pi's brightly colored prompt intended to attract developers to its small and affordable package. Alright. Oh yeah, I don't even have GoodFet checked out on here yet. That would be the first problem. Yeah, I think the serial port on the Raspberry Pi is like TTY ACM 0, but I shouldn't even be using that here. I'm not connecting it to serial, I'm connecting it to SPI. And unless this has some vestigial bits of GoodFet code that still need the serial port, then it shouldn't even be trying to talk to that. Alright, so GoodFet, contrib. Alright, same thing here, gonna copy this. Okay, now it just doesn't have the Python serial module, which is fine. Let's install that. Oh, I think I might need Python 3 stuff also. Oh man, I might have to install some of these other things for Python 3 also. I forgot that this was going to want Python 3. Yeah. So I think it'll need that. And I should also go back and build that other module with Python 3. And maybe I need to find a source for that Raspberry Pi GPIO module. But if it's in PyPy, I should be able to install it automatically at least. Alright. Can I do that? I guess I can do that. Alright, that's fine. Let's install these things. Python 3.4. Alright, and what else? SPI. Do I have to clean this? Okay. Okay, that's a better error. We're at least on the right computer now. So let's just give this a dummy serial port. Okay, let's give it a real serial port. AMA. I wonder when that changed. Yeah, that's got to be it. Okay. Well, it seems like it's still trying to communicate with the serial port. So I think some of this needs changing. Where's that good fit serial port come from? And that face dancer. Okay. So that literally just returns the serial port. I thought it might have been a thing that created a good fit using a serial port. And then face dancer is just one of these. The good fit monitor app. This has read and write. Let's see if this might need a little updating. It's possible this is like designed for a different version of this code. So this has a good fit class with a write command, a fake serial init. that's it. Okay. Okay, so I guess this thing called this like face dancer object actually is not really handling the USB specific parts of it at all. It's just a wrapper around the good fit commands. So I think this object is what we want to replace with that thing that's just called good fit in the other in the file that we monkey patched in. So yeah, we want to keep this max USB app. I kind of want to have this file be named something different. Just gonna call it that for now. So rpi good fit. And I don't want that anymore. Well, I'm just going to try that and see how far that gets me. No. Okay. All right. Just trying to see how this is supposed to fit together. So, I mean, This write command is typically sending something to the serial port on the MSP430 where, it does something. And there are different little sub-applications in the firmware that know about different groups of commands. So like here, for example, there's an application in the firmware that's specific to this max USB that the face dancer uses. So how does this fit in? Yeah, so this seems to be that same write command, but of course we're ignoring most of it. And where did this actually break? Oops. Face dancer FTDI. Verb, huh? Do I have any good editors? Actually, I've been trying different strategies for editing code on the Raspberry Pi, and I think so far my favorite one is to mount an SSH file system from the local machine. I think I might need to install that. But in the meantime, I've probably got a couple of editors here locally. Acquired positional argument, huh? Yeah, I think it might be best to take a look at how that Max USB app is doing SPI transfers right now, because that's what we want to hook into. So this device is what we're plugging into. Oh, this seems to have changed pretty significantly since it was written. So I think that the patched version of GoodFet that we're looking at seems like it was only dealing with a single command, whereas here it looks like the firmware has been extended to do more of the work on its side, and so there are several different commands that it can accept. So I wonder if maybe the easiest thing to do here is actually to roll back to an earlier point in this repository. It'd be nice to just see if I can get this working as it was written. So well, that doesn't tell me exactly when it was added, but maybe we can just get this general vicinity of time here. Oh, can I not copy that? I think this screen config might be interfering with my ability to copy paste. That's annoying. Let's see if that works. Grab commit. Oh, did that not match anything? Oh man, maybe I'm just going to exit screen and work around that particular roadblock. Okay, that's a little easier. Okay, we are now very far in the past. Let's see if that actually works. That wasn't even the right place for this file, okay. Oh, let's take a look and see where we are. Client, contrib, hardware. Maybe client wasn't even in here? Or maybe it was in here. No? Interesting. Wow, okay, so I guess the client wasn't even checked in before that was. So this is like some serious archaeology. Wow, this might be harder to get working than I'd expected. I'd actually have to like update some of this code in a more serious way. I think that's what I want. There's a mouse emulation example. That's nice. I wonder if anybody on the interwebs has a newer version of this that would be easy to find with Google. If not, I mean, it seems like it wouldn't be too bad to update, but like we'll have to look at how those different commands work, and I mean, a lot of them seem self-explanatory. It's just implementing a bunch of things. Well, there's the Beagle Dancer, which we could try. Also, I wonder if it's maybe just not done. Well, let's see if this repo has anything different. Yeah, Huh. That's interesting. So this is a pretty old version of the repo, and I don't see clients in here at all. But maybe this is just somebody's like subset of the repo. Oh, okay, yeah, I think they just made a really bad subversion to git clone here. It's fine. Well. Yeah, not so much to go on, but it's fine. Maybe we can look for old versions of that Max USB file and try to see what version might be comparable to this kind of Raspberry Pi I/O shim here. So let's see, we're back on master. So the interface, let's take a look at this Max USB app. So I'm curious about the changes that occurred when this was introduced, and because I think I would expect that this file maybe didn't even look quite the same before Max USB got its own like application in the firmware. Because I think we're looking for something where there's a Python file that's speaking the Max USB protocol, but it's actually just backed by a pretty generic SPI device and isn't expecting direct firmware support. Because that's the situation we're finding ourselves in now. So, Oh, such promises. Back in 2014, Face Dancer will be forked. When was this introduced? I guess this was probably just one giant commit with all the client code. How does this work? Oops. Always forgetting the syntax for that. I guess that was right. Yeah, so Face Dancer wasn't even there. This is the first. And it's coming up with the GoodFet Monitor app. Maybe this is closer to what we want, because this doesn't seem to be a special application. Oh yeah, and it has that verb that it was looking for last time. So when did we change away from that? I suspect maybe this was a larger commit than just what that implies. No, that's, interesting. Oh. Maybe I'm just getting confused by, I guess these didn't change over time so much as new versions were added. So I think that Max USB app is something that relies on firmware support that we don't have now, but this Face Dancer itself is just using GoodFet Monitor app. Who uses Face Dancer, and are there still useful programs that use Face Dancer but not the Max USB app? GoodFet Monitor app. I think those are all going to be using Max USB app. And that doesn't really have much in there either. Yeah, I think this is where we're crashing the first time, because we're ending up in this code, which is trying to write a register, and it's expecting this. And like, I mean, it would be feasible to go through and re-implement all of this, but I suspect there's a version of this that exists somewhere. that might just not be on GitHub. No, this would be, it was on Subversion and SourceForge, wasn't it? I wonder if this has any breadcrumbs. Yeah, this used to be SourceForge. Yeah. Oh, SourceForge. This might actually be more like the history we want. Let's see what some of these changes did. And this might have just been the very first introduction of USB at all, so this might be too early, but yeah, I think that's just all of USB. That doesn't seem right either. This seems to be the first version of Max USB app, at least. And it's using the commands that we don't want to have to bother with. So, was there anything before this? Doesn't look like it. Let's check out the Face Dancer serial example. This is talking about a rewrite. It must have been this rewrite. So I think what we want was right before this commit to see what, if anything, the USB support looked like. Okay, and these are the old clients. Okay, maybe these are still around actually. Because I'd been used to these, but I guess there might just be yet another parallel way of doing this. So goodfet.maxusb. Yeah, let's see if these are even still in the GitHub repo. goodvet.max USB HID. Great, so there's a warning, but I guess they haven't removed it. And that might be worth a try. Okay. Is this Raspberry still ready to go? Okay, let's do the thing that the README in the contrib directory says was supposed to work, and see if it actually does work if we use the older client. So we have Rasp Dancer. Okay. Let's try something slightly higher level, maybe. Well, it's hard to tell whether this works or whether it just has terrible error handling. But it's promising, I guess. I can try plugging this into something. Yeah, sure are some trains happening. Plug this into some laptop. I mean, I don't know if this is supposed to give me any information. Oh, now it's got a non-zero revision for the Maxim chip, which seems good. Well, how about I/O test? That seems nice. Hard to know what it's supposed to be doing, but let's get some more information. All right. Does seem to be trying to do some stuff with SPI. Oh, you know, I probably need to be privileged to run this. Let's try running this root. Well, I mean, I would expect it not even to get as far as displaying this revision number if the permissions were a problem, though. I'm curious what the permissions are. I guess I'm probably in the SPI group. Yeah, alright, that's fine. Warm cat. Alright, well, let's see if we're actually getting any SPI traffic on the oscope. Oh yeah, here, let me get the camera on the scope. When it seems to be hanging, it looks like it's going into a loop polling I/O. So we can at least get an idea of how fast it's going when it's getting nothing done. All right. Sorry. Looks idle at the moment. Should probably just look up which pins are which and actually set up the logic analyzer properly. Oh. I guess I reset it somehow. Yeah. That is some nice fast SPI there. It's 25 megahertz. It seems to have two different frequencies. Wow. Yeah, the faster frequency that it's flipping to is 25 megahertz. Where's the slower one? Not really sure why it's switching. That might be like frequency scaling on the processor. It's 15 or so megahertz. Alright, well that should be fine. Alright, well I think the next step here is just to hook up a logic analyzer so we have maybe a better, well I guess there are a couple ways we could do this. We could go at it from kind of the hardware side or the software side, and either just hook up a logic analyzer, look at the traffic and see what's going on, or kind of go from the software side and try to see like where is this hanging, can we run parts of it without it hanging, how much can we get it to make progress. Might do a little bit of the latter just because that's kind of easy from this point. Oops, we want that. So yeah, if I run this HID device, then I was noticing that I think the first time I run it, it gives me a revision number of 0, which doesn't seem right. So maybe it's still resetting or something. And then I run it again and it gives me a revision which seems plausible. I don't actually know what it's supposed to be on this chip. And then it tells me it's starting a HID device. And it seems to do some communications for a while after that point. Then there's also this other, oh, there's actually a bunch of these. So the other one that I had played with was this plain old .max USB that seemed to have some kind of low-level debugging. So info is just giving me that revision. Oh, and this is still using all the... I mean, this is like a different version of the Face Dancer libraries than I wrote the thing for recently. This doesn't seem to be saying anything. I'll give myself an easy ground here. Well, it's still communicating. Anything else we can try that might give us more info? Or like a verbose flag we can do? Don't want host. Maybe an FTDI device? Oh wow, is this all just implemented right here? Oh, okay, that's more straightforward than I was expecting. This definitely has fewer layers involved than the newer programming interface that we were using before. And the descriptors are pretty low level here. Just putting them together bit by bit. Well, byte by byte. Well, okay, so I mean, I don't see any like optional debugging stuff here that's not turned on, but maybe the read and write register functions have something we can do to enable like some low-level debugging. So, good fet max USB. Okay, so that is going to be the old version of the good fet max USB, which is what we want right now. It even comes with a great warning. As of 2012, this code was obsolete-ish. Okay. Well, and that's also kind of a problem, because now these are using that Max USB app. So maybe this is still too new. Maybe we have to use these old programs, but maybe we also need a version of this that does not use Max USB app. Because that would explain, well, I don't know. I mean, we are getting some I/O. Or maybe this version, I'm seeing a command 10 and a command 0. But the patch seems to be written for something where there was only really one command that did a read and a write. So that might be what this command 0 is. So what is this command 10? Setup. Yeah, maybe that's what's causing problems. Oh, maybe that's not important. Maybe it's being intentionally ignored. Well, in any case, I don't see debugging stuff, so maybe we add some. Let's just print out what's going on here. This version was probably not Python 3. I think this version is Python 2. Pulling for something. So these are going to be, like, each one of these is going to be like a read or write register at the level of, you know, this Maxim USB chips interface. But this looks like it's in some kind of main loop kind of thing. So maybe we can get some slightly higher level debugging. So what does the main loop for this stuff look like? Let's look at HID. HID should be simple. Client.hid init. That would be a great place to put some debugging. So let's turn that very verbose print off and go for something that just tells us what IRQs are being processed. Oh, I think I'm going to want those to be in hex. Okay. You know, it's also possible that this code is all working fine now that I'm figuring out like which versions of what I want. And that now we're starting to hit some things that may be hardware problems. So I think we want to plug this into a Windows machine. USB. So we're still getting this? Yep, that's still streaming through. And okay, I just plugged it in and nothing seemed to happen. So it might be time to just take a look at the electrical state of those lines. Oops. Okay. was just trying to probe the D plus and D minus on the back side of the board here where it's convenient, and I'm getting something that looks like ground. Not the most convenient thing to probe. There's the SPI clock, just our old friend. And that's the V-bus I have on the back, but I think that's supposed to be ground because I think that's separate from the V-bus on the USB client on the other side, which I can't quite get to easily. When I probe D plus and D minus on the back, I'm also getting ground. Let's pull up the PCB layout. Oops. Alright, here's the little board we fabricated. And the component side here is hard to access. Well, let's maybe just unplug this from the Raspberry Pi and do some continuity tests. I think that might be the easiest thing, because it might just be something is shorted. And this could just be a whole lot of chasing red herrings. So, like, if either of these resistors, for example, are actually shorted, then that could cause this problem. So, let's take a look at that. Yeah, let's see if that angle helps. All the wires. Oops. Did I crash the Windows machine? I think think I might have crashed it in some way that involves unplugging the mini DisplayPort cable at the wrong time. It'll just hang out over here and reboot. Oh, now Windows is updating? Great. All right. Don't see that being shorted. I mean, that is clearly, but... Okay, this... I don't think this problem is that stupid. Alright, maybe it's time to actually plug in the logic analyzer. Alright. What a great time for the Windows machine to update. Alright. Yeah. Right. Alright, trusty Logic 16. Just using this for reference. Yeah, this does have the... So that's also interesting. I don't think we're using the interrupt for anything. I think it's just being pulled. So I guess this is just left off for future expansion. I think we just need the SPI bus proper. This does have reset. I don't know if that's being used either. And I don't even really care enough to hook it up to the analyzer. But these four, we want those. And that's our ground. Okay, let's plug all this stuff in. Brr. Tuco's staying warm. Alright, so I wired this up kind of left to right, top to bottom, so that should be clock, then SS, miso, mosi. So yeah, nothing yet. Let's go ahead and add a SPI analyzer. Okay, let's get the Raspberry Pi going again, and also the computer finished rebooting so I can get the chat back up. Alright, Raspberry Pi is booting. Okay, where were we? We were running some of the older examples. Like goodfet.max USB HID. And let's try doing that with the analyzer running. That is not getting anything. Okay. I will check over my setup to see if I did anything dumb, but I should first get the chat going and get a quick thing to drink. Is the stream green? The stream is red, video output low. Alright, I'll be right back. I'll give you Tuco cam. was just checking the chat briefly and noticed a comment to check whether the good FET has a clock. But yeah, this doesn't have a microcontroller. We just have that same chip we were using earlier, but connected to the Raspberry Pi. And it does have its own oscillator, which we could check to see if that's running. That might be a good thing to do since we mounted it kind of weirdly. Oh, actually, let's just go with this. Alright, like, we should be able to capture something from this info command at least. But maybe this is just wired up wrong. Ah, yeah, this is, I think, rotated from how it is supposed to be attached. I'm lucky I did not ground VCC or anything like that. When it comes to ground, I trust where my ground plane is connected much more than I trust my memories of the Raspberry Pi pinout. Oh, no, it wasn't rotated. It was just actually shifted down. Yeah. Let's see if we can actually match that up with the layout. Okay, so this is upside down. If I hold it like this, it'll match, for whatever that matters. Yeah, okay. I think I just had this wrong. That is strange, though. Yeah. This is also mirrored relative to how I'm holding it. So that's ground. Then that is whatever this is that is too small to read. Clock. Okay. Many ways to get this wrong, and only one way to get it right. Alright, that should be better. this actually the transfer we're looking for? It looks like it's gonna register right or no? Oh, I really wanted this to be in hex. Okay. All right. Well, let's try to get a little bit more data here and then try to make sense of it. Let's try to be the HID device. And it's just hanging out there. Alright, well it looks pretty contiguous once I told it to start. This is probably too low level to be debugging this at. I mean, here's a list of all the transfers. It's a little bit better. But, yeah, maybe let's see what register this is polling. Alright, datasheet. Let's actually save this and get a table of contents. Is there no table of contents? Alright, fine. Here's the registers. I think we also want just like the SPI command format. Because I think there's just like a byte that indicates like if you're reading or writing and stuff, and I forget how that part works. I think I skipped over it. This doesn't look like the full data sheet. Is there like a manual that is separate? Programming guide. I think that's what I want. Yeah, okay, so that first byte is a direction bit, register number, and this other command acknowledge bit that I guess we need to know the value of pretty frequently. Okay. So what are we actually getting in a loop doing? Looks like it's these 4 transfers repeating. So 580680 are the first bytes we're talking about. I guess those are all reads. This bit is 0. And what is so 580680? Let's just get the register numbers for all those. Starting with bit 3. So register 13 or 11, 0, and 13. I think that R0 is some kind of indirect. Like, I think the first several like low numbered registers are used for indirect access to the other ones. Oh no, okay, R0 is the endpoint 050. Is it trying to dequeue something from the FIFO and never finishing it? Okay, and 11 and 13 make sense. Those are 2 of the interrupt status registers, endpoint IRQ and USB IRQ. And what are we getting back for those? Oh, maybe I'm misunderstanding the format here. Let's see what's part of a transaction and what isn't. So this is 5.8. That's one of these interrupt reads. And then that's the response, 2.5. Okay, so these zeros are not even commands. So it's not. This has nothing to do with the endpoint 050. The 0 is just the second byte in all of those other transfers. So all it's doing here is polling for interrupts. And so 2.5, what does that mean? It's getting the same status for both of these. Okay, no, it isn't getting the same status. This 2.5 is left over. This is like a dummy byte when we're issuing this command. So this 6.8 here is reading from register 13. So that's reading the USB IRQ status, and then that's a dummy byte. Then this is the response. So then master in, slave out. This is the one under the timing here. The 0 is the response, and this is a dummy byte. So USB IRQ is all zeros. Is that just electrically not seeing a host attached? And what about the other one? So here, 5.8. Yeah, that's register 11, so that's the endpoint IRQ status. And that's receiving this value OX19. So what is that telling us? Register 11 is OX19. So we have this flag. So these look like individual endpoint IRQ flags, which that's a little weird. I don't know why we're already getting traffic on those endpoints, but so now my question is, okay, so if this flag is set, why are we not responding to an in on endpoint 0? Like, what is the GoodFet software supposed to be doing about this? So maybe we can get some slightly higher level debugging. Slightly higher level. So what are we doing in here? I can see why they wanted to clean up this version of the client. So I think that's... we want that hidden it loop again. Yeah, and that's not even in a HID specific object of any sort. Like, I wonder if this is something that has to do with the response to an SPI command. Because I thought when I had this printout, the values were getting... Oh, actually, yeah, I did add that print earlier, and it wasn't 0. So we're not seeing that. We're just seeing this. Oh man, I don't know what these actually expand to. I assume this is something about bytes available on endpoint 3 in, and likewise with 2. This is like buffer space available. But yeah, so we're getting this endpoint 0. I think this is space available in the transmit buffer and available in this transmit buffer. So that seems fine. I think it's just telling us it's idle. So, I mean, so like, how does this get started? I mean, in general, USB will get started by first, like, kind of electrically turning on the pull-up resistors to tell the host that the device is there, and then we'll start responding to enumeration requests. But, I mean, we aren't even seeing the right electrical state on the USB lines with the scope. This is pretty minimal. Okay, USB connect is part of what we want here. BB gate, BM connect. It might be nice to make sure we're getting to this point at least, or try to test the connection in isolation. How do we get there? Should be before that HID run. Oh, this is frustrating. This feels like it could easily be just some kind of electrical problem on this board. Let's see what the USB port is doing when I don't have anything plugged into it. testing my scope with some other voltages. Getting nothing. Like, I think when this is actually successfully in USB connect mode, even without anything plugged into that port, I would be seeing this with a non-zero voltage because of the pull-up resistors that it enables. So, I wonder if I can just do that connect operation by itself and look at that in the logic analyzer, and if that might be simpler than, like, the polling for interrupts is very chatty, and it'd be nice to avoid having to sift through that. So I'm just going to maybe modify this to not run the HID main loop. So this should just put it into connect state and then exit. There's a little bit of traffic here. Oh, there are some key combinations. I always forget to go to the previous and next bit of traffic. Those would save me enough time that maybe I'll look them up. Oh, N and P, is that it? Great. Okay, we got a few things, and I can also look at them down here. I wonder if this is that same interrupt value we were looking at before. Anyway, let's specifically look for that transfer that should be turning on the USB pull-ups. Okay, register 15. Oh. Looks like this one might be related, 7A. Let's look closer at what the other bits here are. So it should be a 8-bit register, right? Yeah, that's 7A. And then that value, OX19. Suspicious that it's the same as the interrupt value we like, but oops. Yeah. Connect. That doesn't look right. Oh, right, that's not the right place to look. That is where the input value comes in. What we actually want is this value, OX40. Which also is not right. That's a disconnect. What we really want is 48 for connect. Okay, that's the connect. So this is doing a disconnect and then a connect. So that should be turning on the USB port. Can we see that on the scope? I'm just seeing ground on both of those. Nice if I could probe those resistors that are on the other side of this board. Oh, that's not super happening. Yeah, it'd be nice to have like a little interposer to get out that. One downside of having all the components on the underside of this board. Well, I think I can get at that crystal though. Maybe we can see if that's oscillating. I mean, this seems to be communicating on the SPI port, but yeah, it's concerning that I don't see the pull-ups coming on. And even getting a ground on here is super annoying. That crystal does not seem to be oscillating. Maybe it's time to do some tests around the crystal. Yeah, it's really hard to probe anything with that Raspberry Pi connected. So off it goes again. Alright, well, I can do some more multimeter buzzing. And I have not been having good luck with this stream. Low quality, low lucky stream for a low luck week. I mean, there's certainly some opportunities for that to go wrong. Let's have the file up for reference. What is that? That seems like a problem. Cool. Finally a real problem, maybe. So where is that? That is a ground. And it does seem to be a dead short to, yeah, to that. This is also an intentional ground. Oh, that crystal. Such a weird place for a weird crystal. Might have just gotten something under there. Oh, it is hard to tell what is conductive debris and what is just regular non-conductive debris, so maybe I'll wash this a little bit. It is often tempting when I have a really subtle short to just apply current across it and see if the thermal camera can help me. And I thought I tested both of these for shorts when I put the crystal on, but either I missed something before or this is conductive debris. Alright, let's test this again, and if it's still a short, maybe I have to remove the crystal. Yeah. So it could just be this solder ball on this side. Oh, maybe it is closer to the edge than I thought. I don't know. Let's hit this with the flux pen. Oh no, somebody is just... Okay, I know I know people are trying to get my attention in the chat. Let me try to get back in time to when whatever you're mentioning was on screen. Sorry about the asynchrony here. So, oh, you're talking about this little one here? I think that is a bridge from ground to ground, so that might be fine, but might as well take that off anyway. I don't think I actually had a, well, like, so the fill on the top side, I don't think is actually supposed to be grounded, but I think maybe that's why it was grounded. But that isn't our only problem, since, I mean, if that was the only short between ground and the polygon on the outside, then, or not the polygon, but just like the unmilled material in this case, then maybe we can at least narrow down the other short. Is that the one? Is that the one you were talking about in the chat? So, oh, that might still be part of it there. Oops, sorry, there's stick vise. And okay, that does isolate the plane back from the ground again. Let's see which one of those was shorted to the crystal. To the plane, which is definitely not where we want the crystal shorted. It's probably still under here. And let's see if we can get a better angle in there. So these should be lined up the same way, I think. Yeah, it looks like there's a bit of a grounded area in here that is maybe getting shorted to that. So I think first thing, I'm just going to try adding some more flux and reflowing that solder ball. Maybe use a little bit of braid. I think there's just a little too much solder in there. I'm really not using this vise as it's intended because I'm trying to angle this a little bit. It is annoying that even if this does work, I'm going to have to port my little example to the super old API, or port this board to the new API, which seems like the responsible thing to do, but also a lot of work that I'd rather avoid unless it seems like it'll actually be useful. Well, the bridge I can see is gone. Let's see about the bridges I can't see. Yeah. That is the bridge we want to get rid of. I think I can see it now. I think there's just a little too much solder. Very slightly. I mean, there's like way more solder than normally you would need, but very slightly too much for this particular weird thing. I think I cleared the thing on the left. Now I'm just bridged with the one on the top again. Oh, come on. That might be it. Let's test it with the meter. Yay. Cool. I think that looks good now. Yeah. Okay, we no longer have the crystal grounded. This might have more chance of success now. Let's slightly wash this. Oh, where did I put that brush? Alright, let's put this back on the Raspberry. It's back there. Still kind of hard to probe the crystal, but let's just boot up the Raspberry Pi and see what happens. It's still doing that thing where the first time I run it, the revision comes back as 0. But let's take out that latest hack and just get back to the code we're trying to test. Right? Can we see this oscillating? Can we see any pull-ups? Either of those would be nice. Crystal is no longer grounded, but it doesn't seem to be oscillating. It's hard to get a decisive probe on this stuff, though. Yeah. Huh. Just a DC voltage on the crystal, like it hasn't started up yet. And still just ground on the USB D+ and D-. I don't remember at what point in initialization this actually starts the crystal. Well, we have some SPI traffic here. I mean, the Max chip is definitely responding over SPI. It's at least doing one thing right. I wonder if I can probe any of the other crystal adjacent signals. Well, like probing either side of the crystal would be nice. But so far I've only got, there's only one side that I have been able to easily probe. Can I do without Ethernet? I had Ethernet attached earlier because of that GitHub problem that I ran into, but I think I can deal without Ethernet now. Yeah. Wi-Fi. Oh! It is oscillating. Okay, I don't know what changed. Maybe I just wasn't getting a good probe before. That looks like 12 megahertz, but let me get a more solid grip on it. Okay. That seems like a good sign. How about the USB pins? Still ground. Well, let's try plugging in a USB host. I don't think this will work if we're not seeing a pull-up, but maybe I'm mistaken about how this is supposed to work. Let's grab a cable. Here's a cable that I already know works. It's just plugged into this Mac, or into the hub rather. Oh Jesus, there is some smoke. Well, yeah, as we've established, this particular USB hub does not have a lot of current limiting. I didn't actually burst a trace, but you can see the one that got warm. Huh. That did not happen before. Let's do some multimeter probing. Man, I'm pretty sure I actually checked for this particular problem. Here we go. Yeah, sorry. That's what I meant to be showing. Slightly warm trace there. I also checked for that shorting to the case, but let's go through that again, because that seems like a potential issue. Okay, so it was between that via right there, and is that just, what is that? Okay, I think that's VUSB target. I keep trying to arrange this to match Eagle, but it's always like the orientation that needs to be mirrored. So that's VBus going here. Okay, so it's only running to that chip there for VBus sense. And so presumably something under there is shorted to ground. Well, if I were shorting VBus, that certainly would be a reason for the USB device not to be getting any power. Ah, yeah, okay. It's not actually shorted to ground, or it's not shorted to signal ground, it's just shorted to case ground. So this is a problem up on the top side here. I thought I checked for that. Guess not. Or it might be... Oh, what's going on there? That looks like maybe a tiny, tiny bridge between between case ground and this polygon. Yeah. Oh, I think I might have even just rubbed that away with my probe tip. Okay, yeah, there was a bit of conductive debris in that gap right there that was connecting these together, which isn't itself a problem, it's just not necessarily something I want. Because this polygon is ideally not connected to anything. It's just like copper that is left over after routing. And these ideally are just connected to the case ground, I think, the way this circuit's designed. So I guess V-bus is shorted to this plane, which was then shorted to case ground through that bit of conductive debris. Okay, so those are no longer shorted. That's no longer shorted. Just this. And where might that be? I think this gunk here is left over from sanding? What is that? I don't think that's conductive, but let's wash it away just in case. That one's not helping. A lot of places this short could be hiding, including under the USB connector and under the USB chip. That's the short that I want to clear. I mean, based on this trace being the one to get warm, it does seem like the short would be Well, no, I was going to say that it would be on that side, but actually this is, I think, where the power comes in on this via. Is that right? Oh, no, that goes under it goes underneath right away. Gotcha. So, yeah. I think that if this was shorted, it wouldn't have overheated the trace where it did. Well, might be worth just pulling out this via to separate the two, since the vias are easy to redo when they're not under stuff. Via. And I think, if it isn't detecting VBus, I don't know. It depends on how the chip is configured, because that's like a software feature. It just has a comparator you can use to see if the host is plugged in, but depending on how you wrote the driver, that may or may not actually matter. All right. Yeah, that seems all right so far. So then we want to see if the top polygon is where am I touching this? Huh. Alright, that's the via. Come on, focus. Yeah. Well, it could be either of those two. Don't see anything here. We'll check this capacitor first, but if it's not this capacitor, it might be under the chip, which would be annoying, but it can be fixed. It's just annoying. likely it's the problem with under the chip, but it could also be something here. Whoa, was that it? I think that might have been it. Sweet! Yay, no pulling off the chip yet, I hope. Okay. That seems good. Hey, Tiger. Aw. Alright, Tuco. We can do this. Let's maybe apply power in a way that is slightly more current limited. Oh, that's right, I still have not put that via back in. Let's do that before plugging this back. Oh geez, this connector is not very good. It's already starting to come apart. Okay. It's really not heating the wire, it was just heating the solder. That's better. I should really try that tip somebody gave me a little while ago of dipping the wire in flux. That seems like it might have helped this one. Tight space. Okay, Good old overheated trace. Okay, current limited 5-volt supply. I don't have a USB adapter for this handy, but I think I'm just going to temporarily test it to see if it draws any current. Cool. Only draws current when I short it to ground. Otherwise, it is smaller than my power supply can measure, which is what I would expect. Okay, let's try this again. Alright, just booting up the Raspberry Pi 3. Maybe this is why the Windows machine rebooted earlier. Maybe that was its... Maybe it didn't have anything to do with DisplayPort, it was all USB. Oh man, Windows keeps telling me I need to update the printer driver for this printer I never use. Probably should uninstall the driver. Okay. Let's see if we have anything. Back to the Pi. Max USB HID. Ooh, neat. It crashed after handling a setup packet, which sounds awesome. Yeah, I'm not gonna worry too much about why it crashed because of that packet. Getting a packet at all seems like a pretty great step in the right direction. Let's see what else we have that works with this old framework. Maybe mass storage? I guess it wants a disk image. Let's make a little disk. Yeah. Whoa, handling more setup packets. Windows is telling me the USB device was not recognized. So yeah, Windows is not extremely happy about this. But it does seem like the hardware is working now. Let's see if I can find anything that at least works well enough we can demo it. It does look like, unfortunately, some porting is in order to actually make the program I wanted to run work with this. Did we try FTDI? More setup. We getting anything from Windows? This device Windows likes. Installing FTDI emulat. Here, let me plug this back into the Windows machine so we can both take a look at this. Yeah, this is the cable I want. Yay. Alright. So, we'll get back to that in a sec. I think we want the device manager. Oh geez, I kind of want a keyboard. Device manager. There's our FTDI emulat. Is that at all related to what we're supposed to be seeing? Let's take a look at the source code for this example. Yeah, I wonder if this was calculated incorrectly, actually. And then we have a 2-byte header, I think. Yeah, that's the length in the string. So Windows and the Mac's USB are both doing exactly what this application is asking. Well, all right. See if we can find out why, or like if any of these actually are usable. Like this FTDI, where is it getting its data? Does it get data at all? I guess it's just printing stuff. It looks like the FTDI driver does not like it, which is why I'm inclined to try something that is not proprietary so that we can use like a standard device class. And so we had HID, which didn't seem to work. Well, the HID was crashing after a specific setup request, which is weird. Well, it was exiting. We don't even know if these two things are related. It might just be exiting because it wants to exit. That's not something I did, is it? No, that's just the patch. And the disk image, like that's running, and I'm getting a bunch of some kind of traffic. I don't see any errors in Windows. I do see what might be a USB mass storage device. Try to remember how to format disks in Windows. Yeah, Windows, it's seeing some kind of USB device, but I'm not getting like a disk in the disk manager. So that seems like it would require some more investigation, like looking at it with maybe a USB analyzer. Do we have any other clients here? I mean, DFU doesn't sound too interesting. That's like firmware updates, which I don't have a client for handy. And host is also not super useful with the hardware configuration I'm using right now. So what is going on with HID? Why would HID exit? There is like a HID loop or something. Yeah. That does seem like it should be an infinite loop, doesn't it? Whoa, check out the semicolons. I used to do that all the time. I still do occasionally when I'm switching back and forth between C and Python a lot. I mean, does this have any calls to exit? It does. Huh. Oh. I guess this program is designed to type a string and then exit. Maybe I'm just, again, not using it correctly. This code definitely seems like it's seen better days. Okay, I guess these are all hard-coded. Well, maybe I'll just remove that exit to see if that's actually causing the problem, or causing it to exit without otherwise warning. Well, now Windows is saying it didn't recognize the device. I suspect that particular problem might be, I think that might be disconnecting the device for too short a time. Like if you just like really, really quickly disconnect a device and plug it back in, it won't enumerate it correctly. Yeah, if I manually unplug it and replug it, then... Oh yeah, I think it's typing. Let's switch to the computer here. Is that the computer? Yeah, so somebody is typing into the device manager, and if I unplug it, that stops. Let's try to get like a notepad or something. Great. Okay, that seems like a small victory at least. So that is coming from the Raspberry Pi Python with the old version of the Face Dancer framework. And I guess this layout works when I don't have short circuits in it. So let's see, what were our problems this time? A couple of starter bridges, using the wrong version of the software, and I guess a bug that causes this demo to exit after typing it once. Or maybe it's intentional, I don't know. Hard to tell. Oops. Yeah, what happens if I'm curious if it does actually successfully just type it once without that exit. Alright, so I'm going to have this ready to run, but let's switch to the other monitor. And clear all that. It could also be that I need to unplug this first, and then run the script, which I hope I actually still ran, and then plug this back in. I don't know. I think that exit might be ill-advised. Windows is complaining about this device. Well, it hasn't exited yet. Okay. Well, if I unplug it and plug it back in, then I think it is still exiting prematurely. It's exiting during the USB enumeration process. So I think that workaround was actually necessary. And the disk, I don't know what's up with the disk, but I think this might be nearing a pretty good wrap-up point. I've at least got this board working. It's less useful than I was expecting it to be, because I didn't realize that this would require some porting. But I guess at this point I need to figure out what to do next. Since this footage is still probably useful as far as like just demoing another assembly, there might be parts of that that are useful. But I don't know, this might be a dead end, since I don't know if it's actually worth doing yet another porting effort to just get this TCB87 dongle working using something slightly more modern. The hacked up Great FET actually isn't so bad compared to some of these alternatives. So maybe I'll actually just document that a little bit. But I'm starting to run out of energy tonight. So I'm going to use the restroom and then see if Tuco wants to play a quick game of Bolt before I wrap up this stream. And I'll catch up on chat and see if I can answer anybody's questions and all that. Hey Tuco, you seem awake. You seem kinda awake. Stop this recorder. Stop this recorder. Hey Tuco. Hey little cat. Oh, I had a pocket full of bolts earlier today, but then I changed pants. Where are all the bolts? Stretch. Good job, little guy. was just catching up on chat, and there was a comment from Wildmania that I changed a file, something arpy, that might have been an issue. Not quite sure what that would be referring to. Like, do you mean in the Face Dancer software? So the files we were dealing with here, that patch that was in like the Rasp Dancer contrib directory in the goodfet repo, that was just like a replacement for goodfet.py. So that change was still in my Git repo, but I think other than that, the only change I had locally was removing that exit call, which was specific to the HID. I still haven't looked into like why the storage device wasn't working. But I'm less inclined to put a bunch of debugging effort into something that seems to be a couple of generations behind what the developers are likely to care about currently. All right, I think I'm going to wrap up the stream for tonight. Sorry, this one was a little anticlimactic, but at least we got this thing working. It just didn't quite fit into the rest of this narrative like I was hoping it might. So I will formulate a plan and regroup and try to let people know as soon as I can when the next stream is going to be and what it's going to be about. You want another bolt, Tuco? Where is it, little guy? He's looking for it under the bathtub. He might be at this one for a while. Any luck, Tuco? Yeah, this seems like a pretty complicated bolt. I think I'm going to sign off without necessarily waiting for him to unravel this entire mystery. So thanks again. Thanks for everybody who joined. Thanks for tuning in. And if you have any suggestions, feel free to let me know on Twitter or in the YouTube comments. And let me know what you liked and what you didn't like, and I will try to take that into account. Thanks, everyone. I will see you next time and on the interwebs.